You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your Cloud Plus certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Processor optimization strategies are essential for cloud platforms aiming to deliver high performance, efficient utilization, and cost-effective resource allocation. Two of the most impactful techniques used in cloud computing are simultaneous multi-threading, also known as SMT, and processor oversubscription. These methods allow physical hardware to support more virtual workloads by optimizing how central processing units are shared and scheduled. Understanding how these techniques work and how they affect performance and architecture is a key learning goal for Cloud Plus certification candidates. The Cloud Plus exam includes topics related to CPU allocation, virtual machine behavior, and the impact of multi-threading and oversubscription. Candidates may be asked to identify the root cause of contention, evaluate performance metrics, or recommend configuration changes. Recognizing how many virtual central processing units are assigned to a workload, how those vCPUs relate to the physical hardware, and how the hypervisor schedules them can help ensure performance predictability while maintaining efficient use of cloud infrastructure. Simultaneous multi-threading allows a single physical CPU core to run multiple instruction threads at once. The most common implementation of SMT is hyperthreading, found in Intel processors. With SMT enabled, a single core appears as two logical processors to the operating system. When one thread stalls, such as when waiting for memory access, the core can continue executing a second thread, improving core utilization. In virtualized environments, this means each physical core can host more vCPUs without being idle during execution gaps. The benefits of SMT become especially clear when workloads consist of many small threads or frequent context switching. In these cases, the scheduler can more effectively use CPU resources by filling idle cycles with useful instructions. Applications that are I/O-bound or rely on multi-threaded execution patterns tend to benefit most. By contrast, single-threaded CPU-intensive tasks may not see much improvement, and in some cases, sharing a core can reduce performance due to resource contention. Candidates must evaluate workload type when deciding if SMT is advantageous. Oversubscription occurs when the number of virtual central processing units assigned across virtual machines exceeds the number of physical cores available. This strategy increases virtual machine density and allows more tenants to share the same hardware. For example, if a server has 8 physical cores, assigning 16 vCPUs results in a 2-to-1 oversubscription ratio. While this increases utilization and lowers costs, it also raises the risk of contention, where virtual machines compete for physical CPU time. Oversubscription ratios are not universal. They must be tailored to the expected workload. In some environments, a 4-to-1 ratio may work fine for development or batch processing tasks. In others, such as real-time analytics or financial processing, even a slight oversubscription can lead to missed deadlines or failed transactions. The higher the ratio, the more unpredictable the performance becomes. Monitoring tools must be used to track contention and adjust ratios as needed. On the Cloud Plus exam, candidates should know how to assess and apply appropriate oversubscription thresholds. When oversubscription is pushed too far, the result is increased latency, jitter, and performance degradation. Applications may respond more slowly, transaction processing might be delayed, and users may experience lag. Performance issues can also cascade, causing workloads to back up or fail under load. In multi-tenant environments, one noisy neighbor can impact others by monopolizing compute resources. For this reason, oversubscription must be used carefully and monitored continuously to ensure fairness and performance. SMT and oversubscription are sometimes used together to maximize virtual machine density. With SMT enabled, each core offers more logical threads, which can then be oversubscribed at a higher ratio. This approach improves resource efficiency but can also mask performance issues if not carefully tuned. The hypervisor must balance thread allocation intelligently, and administrators should profile workloads to determine how much oversubscription is sustainable. The Cloud Plus exam may include scenarios where candidates are asked to recommend SMT and oversubscription configurations based on workload profiles. Metrics such as CPU ready time and steal time are vital for identifying contention and evaluating oversubscription effects. CPU ready time indicates how long a virtual machine waits in line for access to physical compute resources. High values suggest that the host is overloaded or that the vCPUs are not being scheduled efficiently. Steal time, often reported in Linux-based systems, shows how much time was taken away from the virtual machine by the hypervisor to serve other tenants. These values are strong indicators of when oversubscription needs to be adjusted. Support for SMT and oversubscription varies by processor type, hypervisor, and cloud provider. Some hardware platforms offer configurable SMT support in the BIOS or UEFI settings, which must be enabled before multithreading becomes available. Hypervisors also differ in how they manage logical cores and assign virtual processors. Cloud orchestration tools may include placement policies to avoid putting multiple high-priority workloads on the same host, reducing the risk of contention. For Cloud Plus certification, understanding where these settings live and how they affect performance is essential. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. While SMT offers performance benefits by increasing the number of threads per core, it also introduces potential security risks. Because threads share certain processor resources, timing side-channel attacks can be used to extract sensitive data from co-resident tenants. This risk is especially relevant in multi-tenant public cloud environments. For this reason, some cloud providers disable SMT for high-security instance types or allow administrators to toggle it off. Candidates must understand the trade-off between increased performance and reduced isolation when considering SMT for cloud workloads. Oversubscription policies differ between public and private clouds. Public cloud platforms often use oversubscription to reduce operational costs and offer more competitive pricing, especially for burstable or shared tenancy instance types. Private clouds, by contrast, may restrict oversubscription to maintain predictability and performance for critical applications. These policy decisions affect how workloads are placed, how performance is guaranteed, and how resource contention is managed. The Cloud Plus exam may present scenarios where candidates must evaluate the appropriateness of oversubscription strategies in different environments. Workload placement is a key factor in managing both SMT and oversubscription. High-priority workloads, such as transactional databases or video streaming services, should be placed on low-contention hosts with reserved resources. Lower-tier services, such as development sandboxes or background analytics jobs, can tolerate more oversubscription. Cloud orchestration tools use placement algorithms and affinity rules to enforce these policies, ensuring that resource-intensive virtual machines are not co-located on heavily oversubscribed hosts. Placement strategy is a recurring topic in performance optimization scenarios. Detecting overcommitment bottlenecks requires close attention to performance indicators. Symptoms include increased response times, slower job completion, and higher CPU wait times. Monitoring tools can trigger alerts when thresholds are exceeded, or when application performance drops below acceptable levels. Benchmarking, combined with real-time metrics, helps administrators identify when compute demand exceeds physical supply. Scaling out or migrating virtual machines to less congested hosts can restore performance. Candidates must know how to interpret these signs and recommend corrective actions. CPU pinning and resource reservation are advanced techniques used to manage compute resources more predictably. CPU pinning assigns specific physical cores to specific virtual machines, eliminating scheduler variability. This is useful for real-time or latency-sensitive applications where jitter must be minimized. Resource reservations, meanwhile, guarantee that a virtual machine has access to a minimum number of cores, even if oversubscription is in place. These strategies support consistent performance, but reduce flexibility. Understanding how and when to apply these techniques is critical for tuning cloud environments. SMT can also benefit edge computing and specialized devices where hardware constraints limit the number of available cores. Internet of Things gateways, compact servers, and remote nodes often rely on multi-threading to maximize the utility of their limited resources. By enabling SMT, these systems can process multiple tasks simultaneously, such as sensor data aggregation, real-time analytics, and network routing. Cloud Plus candidates should recognize how virtualization strategies like SMT extend beyond traditional data center deployments. On the exam, scenarios involving processor behavior may include resource contention, poor virtual machine performance, or unexpected behavior due to overcommitment. Candidates may be asked to identify whether SMT is enabled if oversubscription is too aggressive, or whether certain workloads should be migrated to dedicated hosts. Recognizing symptoms like high CPU ready time or inconsistent throughput is essential. Knowing how to recommend configuration changes based on evidence is a key performance troubleshooting skill. Monitoring tools are essential for tracking CPU utilization in multi-tenant environments. Dashboards can show real-time and historical usage trends per virtual machine, per core, and per host. Agent-based monitoring provides additional metrics such as steal time, saturation, and queue depth. These indicators support intelligent scaling decisions, inform placement policies, and guide corrective action. Visibility is the first step in managing resource contention, and Cloud Plus candidates must understand which metrics to monitor and how to respond when performance begins to degrade. Best practices for managing SMT and oversubscription begin with profiling workloads before making changes. Not every application benefits from multi-threading, and some are more sensitive to contention than others. Administrators should start with conservative oversubscription ratios and monitor performance before increasing density. SMT should be enabled only where supported and monitored for security side effects. Any changes to resource allocation should be validated with real performance metrics, not just theoretical capacity. These principles help avoid performance regressions and maintain a stable, responsive cloud environment. To summarize, SMT and oversubscription are powerful tools for maximizing cloud resource utilization, but they must be applied with care. SMT allows physical cores to run multiple threads, improving throughput for parallel workloads. Oversubscription increases virtual machine density, but risks contention if not carefully managed. Monitoring, placement, and reservation strategies all play a role in mitigating the risks associated with these techniques. Mastery of processor optimization topics is essential for Cloud Plus candidates tasked with building high-performing, cost-efficient, virtual environments. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.